Can you hear me back there? Okay, so we have an hour here from 4 to 5. In 1 hour, I'm going to teach you how to be an expert in LabVIEW or FRC. Okay, maybe not exactly, but what I hope to do is show you what LabVIEW is about, and then dig in a little bit to some of the robot codes. You can see that it's fairly easy in LabVIEW to get started and then be successful quickly in LabVIEW. So my name is Doug Norman. I'm an engineer at National Instruments. Worked there for over 20 years. And we're the company that makes the RoboRio. So I'd like to brag that every single robot uses the RoboRio. Not everybody uses LabVIEW, but I hope more people do. So maybe show of hands, who's using LabVIEW right now for programming? Okay, so pretty good. And who's kind of checking it out, maybe wants to learn LabVIEW? Okay, so some new people. So hopefully I can kind of touch on things for both of you. I'm doing this presentation right now at 4 o'clock. Greg will be doing the more advanced presentation at 5:30 for some of you that are more advanced in LabVIEW. You might want to check that out. So a little bit of overview of what we'll talk about. I'll go with system topology. I won't spend much time on this. This is kind of what are all the pieces. You have your robot and the field, the driver station, things like that. What is LabVIEW and why do I think it's a great idea to use LabVIEW? And we'll actually do some examples in LabVIEW, so we'll kind of bounce back and forth between slides and actually go into some code. Then I'll talk about LabVIEW, what's special for FRC, and then also simulation. Who in here is familiar with simulation or has tried simulation? Okay, so hopefully I like to try to pitch this because it's a good way to learn LabVIEW for FRC without having to have an actual robot with you. So you can go home, we let you install LabVIEW on as many machines as you want. You could go home and install this on your own machine, and with just a joystick you can learn how to write code for FRC. And then we're going to look at into the project. So we'll look into the RoboRio project. What does your robot project look like? We'll show you what we've edited to add a gyro to that project. So in the simulation, there's simulated robots that have sensors and actuators on them, and we'll take a look at what you can actually add for code on there. And then we'll look at the dashboard side. A lot of people are fairly unfamiliar with the fact that you can also, on your driver station, you can write the dashboard piece of that. So the upper 2/3 of that, you can write a custom dashboard. So we'll take the gyro and we'll send that to the dashboard. And then finally, along the way, we'll talk about examples and tutorials. Some of them are built into when you install, and some of them you can go online and find. So this is the topology. I'd just like to bring this up so you realize every robot's got a RoboRio on it. I just use it every year, steal someone's nice picture off the web. So if you want your picture on this slide next year, take a nice picture of the robot on a white background. I'm always looking for those. So then we can program this with a real-time program that you build an executable, writing it with LabVIEW, download it to your RoboRio that's on the robot. And then when you're actually at a competition, we have the field management system, or the FMS, people are familiar with. And over on the left-hand side, you're all familiar with, people have a driver station. It's typically a laptop, some type of input. Here I just have a joystick. But then also realize the driver station consists of the lower 1/3 of that, and that's an actual LabVIEW built executable. In fact, Greg's the one that writes that. And the upper 2/3 you have control of. You can use the default dashboard, or you can build your own in LabVIEW if you want. So these are just the basic pieces. So what is LabVIEW? We call it a graphical program. And so it consists of, we call it graphical because you sort of draw your code. And we also call it a VI. So you may have heard of a VI. That is a piece of code. It originally stands for virtual instrument. And so there's kind of three main pieces to this. There's a front panel, and that's where you have your user interface. That's what this UI is here. And then you have a block diagram, and that's your actual code. And your front panel has controls. Those are inputs. And then it has indicators, which are outputs. And then every control or indicator on the front panel has an associated terminal on the block diagram. So for instance, this is where this is being added. So this dial here is represented by this terminal here. And like here's your stop button, here is this stop button here. And then data, you can think of data as flowing on the wires. So a node, for instance, this addition node, doesn't execute until it has everything at its inputs, and then it executes, and then it sends the output down the wire. And then a VI, if you've heard in other languages like a subroutine, a VI can be called as a sub-VI. So we can define this iconic connector, and then once we create this is fairly simple, but once we create this, we could call this somewhere else as a sub-VI. So we'll take a look in LabVIEW. I just wrote a fairly simple example that we can take a look at, and you can take your time and read this here, but the basic idea is, let's suppose that I have a robot, and it's got a shooter. It seems pretty popular this year. And maybe, and I measure this angle, and my angle minimum is 30 degrees, and my maximum is 60. And that could be a left-right angle or up-down angle, or whatever your shooter designed. But let's just say I physically measure those angles, and I hook a potentiometer to that arm. And I also measure the voltage coming off that potentiometer. And at my minimum angle, my potentiometer is reading 0.2, and my maximum is reading 0.8. And these could be different. I could add any numbers in here, whatever I measured. And someone's told me, they showed me this robot on the program, and they said, here's what we have. Now what we want you to do is, as we're driving around and moving this and reading this voltage, we want you to tell us what our angle is, because all we can read is that voltage. And so I wrote a little VI here, and if we just quickly test this out, if I put a reading in here, let's say I put in 0.56, and I run this, and so my angle, my associated angle is 48. And so let's just take a quick look at the code, and it's not important to understand this code, just understand it's a little more than adding two numbers, right? So you kind of come up with, okay, I have this minimum and maximum angle, I have these voltages I'm reading, I have a voltage I'm bringing in, and I have some calculated angle out here. And then I've done a little bit of code to make sure that if I read outside the bounds, I don't measure some crazy angle outside the bounds in case something goes haywire with it. And then notice also that these same names, remember there's terminals here that represent the front panel controls and indicators. So it's good to realize that. And then here's a few nice things that I like about LabVIEW. So one of the first things is, if I just have this is just, I'm going to turn this into what we're going to call a sub-VI. But let's just say I just want to test this code. I can just test it on its own right now. I can run it. And I can press the run button, but I can also press this where I can just continuously run this. So I'm going to do that, and then notice as I click this, it calculates my angle. So this code is running. But notice some of the nice things about LabVIEW here is I can click a probe anywhere I want. So suppose I'm not sure what's going on, and in my code, I want to sort of look at some different places. So I want to look at this point and see this point, and I can set a probe, and then I can run my program, and I can see those values change as I change as my program's running. So it's a nice thing here is just I can click on any wire and see that data while the program's running. And I'm showing you just a number, but suppose you're working with, let's say, vision. If I were to click on a vision wire, I'd get a picture in the probe, not just some bunch of numbers. So the probe's very, very versatile. It adapts to whatever data type that you're clicking on for your wire. So that's one nice thing that I like. Another is execution highlighting. And you can see here I can highlight this and actually watch my program run. So you can see all the values, you can see what's running or what isn't running, maybe in some cases you have a problem. But you can use this execution highlighting and quickly see kind of what's happening in your program. One thing to realize about that is it slows down your program, right? It's actually running slower now, so you can watch it execute. So notice over here, if I click this a couple of times, I'm not getting any output here until it goes through all of that execution highlighting, and then eventually that number will now change. So just be aware when you use that, how that works. And then one final thing I'll show you is how LabVIEW helps you with errors. So When I created these, I just right-clicked, and there's a bunch of palettes. We're not really going to go through all the palettes here, but realize that I picked a control, that's my input, or I can pick an indicator, that's an output. Well, suppose that I accidentally have this as a control. It's really an output, but I accidentally put it as a control. Well, notice what happens. I don't have to compile this and wait for it to come back and tell me you've got a bunch of errors you need to go fix. I immediately get a broken arrow. See on the upper left, my run arrow now is broken. So I can click on this broken arrow, and then what I get is, it tells me I have an error in voltage to angle. That's the name of this VI that I named it. And it tells me what the problem is. I've connected an output of an add to a control. Change the control to an indicator. So it's kind of nice to get not only an error, but hey, here's how to go fix your error. And if I double click on this, it'll go and show me where my problem is, which is pretty obvious in this fairly simple sub-VI. But if your VI gets a lot larger, more complicated, it's nice to be able to easily find this. So I'm going to right click on this and change it to an indicator, and now my run arrows have been fixed. So the last part, as I mentioned, we can use as a sub-VI. And so what I can do is I have this terminal connector pane up here that I can define. So I can go in and I can click on these terminals, and then I can define, like, this is my input voltage reading. I'm going to define this is my output. I could add all these other numbers, but I'm kind of saying here, well, I'm just going to make those some defaults. I don't need to wire them in at this point. So I'm just going to have an input and output for this. I can also go ahead and I can create anything I want to for this icon. So let's say I want to add a little more text here. So I can change that icon if I want to. So now I've added some terminals, and then if I Control H, I can turn on my context help, and I automatically get this help that shows me my input and my output and my name. And here I have a little description that I've put into that. So it also builds up the help for me. So once I've done this, I can now use it as a sub-VI. So let's say, I figured out this code. I don't want to have that code that large in my main program, so I'm just going to call the sub-VI because I know it works now. I've tested it and that type of thing. So I'm just going to create a new VI here, and we'll just pretend this is our robot. I'm just kind of making some stuff up here. But let's say this is a gauge, and I'm going to go to 65 and maybe 25. I'm just going to set a few numbers so it's easier for you to see. I can make these numbers larger. This is my angle. Make that larger. So it's pretty easy to edit things, you can see. We're going to pretend this is the tensiometer reading, right? And my potentiometer, I'm going to say, we know it only works from point 2 to point 8, right? So I'm going to make this 1 and make this larger. So now, and then again on my diagram, notice there should be a control and indicator for these. And so here they are. Here's my potentiometer voltage, and there's my angle. And then I'm just going to take this sub-VI that I created and drag it down here and wire it in, and I'm going to call that code now as a sub-VI. So I've just created a sub-VI, and I'm using it somewhere else in the program. And then just for completeness, I'll go ahead and put a loop around this to show you pretty quick to create a while loop. I'm going to create a control for a stop button. And I'm going to add a little bit of timing in here so this doesn't run. So it only runs every, let's say, 20 milliseconds. I don't want to tell it about speed. And here's my stop button that I created from the diagram. Again, I can make this a little bit bigger. Now if I run this, that loop will run until I click the stop button. And then notice my 0 to 0.8 corresponds to 30 to 60, and then I have it where it bottoms out at 30 and it tops out at 60. And while this is running, notice I can still dig into code. You know, I can still go over to this other code here, and I can have a probe running on my sub-VI while this is running. So you can see that you can probe down inside, you can dig down into your program and start probing around if you're trying to figure things out. So this is all, you know, pretty basic programming, but I think what's powerful here is that you can really get a lot accomplished in a very short amount of time with LabVIEW. Any questions about this so far? Okay, so I kind of answered some of this. Why use LabVIEW for programming? You're quickly successful. So it's graphical, it's intuitive. I think I showed that to you. It's also very used by a lot of engineers. So we always tend to pick the latest, greatest company that's using it. So SpaceX is the latest company. It's very big on LabVIEw. They use it for testing all their engines. In fact, in Texas, they're using it right now. I think it has really good debugging. I showed you quite a bit there. There's more debugging also, but I showed you some of the pretty powerful things. And then we have good support. So there's tutorials that are built in. There's tutorials online. Same with examples. We have almost 50 that are just for the RoboRio. And then we also have phone support during the build season. So the 6 weeks of the build season, you can call application engineers. Those engineers are the same ones that are here as your CSAs right now this year from National Instruments. So there's typically 8 to 10 engineers that are familiar with FRC. Some of them have been on teams and gone through college and now work at National Instruments. And then finally, you can get more support at ni.com/FRC. And I'm going to talk a little bit more about this because the same application engineers have done a really good job of revamping this web page. So if you go there, this is actually what you see. There's kind of these 4 buttons right now. And then in the getting started, this is everything from downloading the software, setting up a RoboRio. It also now has some very nice links to one of the most popular questions I think we get in the booth is, I want to learn LabVIEW over the summer, how do I do it? Or I'll get mentors, I want to teach kids LabVIEW over the summer, how do I do it? And so we have LabVIEW basics courses online that are linked from here now. You can go and work through those. Now below here it talks about tutorials and examples. Those are some more FRC specific tutorials that are available there. And then over here we have, it mentions our discussion forum. So we're always available through email. You can get answers to questions that you have. And then also if you need technical support, I mentioned we have phone support during the build season. But if you're having trouble with your RoboRio, we always have support for hardware. We do a really good job of supporting the RoboRio. And then finally, there's a little more information about who is NI. You know, if all you've ever seen is a RoboRio, that's a very small piece of what we do. We do that because we think education is important. As a company, National Instruments makes a lot of other products, and this kind of gives you more information about who is National Instruments and then why we find it important to partner with FIRST Education. And so if I didn't convince you with that, another reason you might want to visit ni.com/FRC is you can win a RoboRio this year. So you can go here and you can actually, during championship, we'll be giving it away. You can go there and fill out an application to win a RoboRio for your team. And you can do that on your, any place you have a web connection, or you can also come to our booth. We have a booth in the pits where you can actually come and sign up for this. And actually, we're giving away 2 RoboRios. So one is through this, another is, I believe, through Twitter, and there's more information in our booth about that if you want to find out about that. So what is LabVIEW for FRC? I mentioned what I showed you so far was just basically LabVIEW. It's a very generic programming language, very powerful for lots of different applications. But what do we do special for FRC? So to start with, it's our top package. So what you get when you install it is our professional package. The only difference is it's licensed for a year. So it's licensed from January to January, so you can use it all summer. And then we do some other things here. We do a specific getting started window. So when you launch it, it's FRC specific. And we'll take a look at all these pieces as we go along. We also have specific library of VI. So when you see the VIs that I'm using in the robot project, when we look at that, those are all, we call them WPI Live, but they're libraries of VI specific to the for robotics for FRC. So when you look at running motors or reading sensors and things like that, those are all specific for FRC. Then we have projects to choose from to get you started that are FRC specific. I mentioned already examples of tutorials, and I also mentioned that we have the phone support. We also have videos and other documents at /FRC, internet.com/FRC.
Question?
Yes.
So if we're looking to, pick this up, a mentor to learn it, and then teach, the students on the summarize you had noted there, are those, I guess I could probably put this up later, are those tutorials set up in like a, 6-week session or a 12-week session, with, good objective and cutoff points, or is it all just kind of there and you guys kind of dice it up yourself?
Okay, so the question is if you wanted to teach it, are the tutorials set up sort of with a timeline? I don't believe they are. I do know that we have, one of them is actually our full LabVIEW basics course, but it's a long, long video. I think you would have to cut it up yourself. Any other questions? Yes?
So you mentioned that when we get into the professional level,
Mm-hmm.
so
So the question is that you get the professional version of LabVIEW. What are the other versions? How does that compare? Something like it, I believe, like the LabVIEW base version doesn't have a lot of the analysis that you get in the professional version. There's also some toolkits that are added on, like to build, which you sort of have to have for FRC to build an application, things like that. So a lot of the analysis, depending on what you're doing, you may use them for robotics, and you may not.
Also doing vision and control simulation stuff. That's all that added as well.
Right, so Greg also mentioned that includes the vision. So the vision and also a lot of the control and simulation pieces. So I mentioned simulation, and I want to bring this up. So this is nice if you want to learn LabVIEW and you want to learn for FRC robotics, but not everyone has a controller or a whole setup for that. And so what we have done is we have projects that contain predefined robots. And we'll take a look at these in a minute. And the robots all have specific sensors and actuators on them. And they also contain a wiring manifest. And what this is just a list of, for the input and output, like the motors and indicators, what are they wired to, what channels on the robo-relay. And so this would be the same thing. If someone else built the robot and handed it to you as a programmer, they would have to give you a list of how it's wired, right? And you wouldn't know how to program it. So you have to know the motors are connected to what inputs, and the sensors are connected to what inputs or outputs. And then these are predefined robots, and you can't edit them. So at this point, it's not our goal to have you design your robot in our simulation. Our goal is to help you get started learning LabVIEW and programming your robot. And then we'll look at this, and the difference here is you just run on my computer. Instead of running on a target, so instead of running down on the Robo-Rio, you tell it to run on the computer side, and then the simulator will actually open. You can see the robot running there. And if you write this code and get this robot running, if you wired a real robot the same way, you could run the same code on a real robot. And then also the driver station is needed. So just like a real robot, you have to run the driver station in order to get your robot to actually physically move in the simulator. So for simulation, this is all you need. A decent, I say here, a decent laptop. You have to have a dedicated video card. So I guess, for example, it wouldn't run on a Classmate, but it'll run on this laptop okay. It's a little bit slow, but on a nice desktop, it'll run fairly fast. It's just that a physics engine takes a lot of video and memory. And you need some type of inputted device, like a joystick. And then I mentioned also you run the driver station, and you have your robot code. So I mentioned the getting started window, and we'll take a look at this. But these are kind of the areas we want to really talk about. And there's tabs that correspond to these. So there's a project, that's where you create your robot project and your dashboard project. There's tutorials. I mentioned this because what we're going to go through here, you can actually find these tutorials on this tutorials tab. They're built in when you install the FRC package. So we're going to talk about simulation and integrating examples. You can find that in the tutorials. And then support, we'll also talk about the example finder where you can find these examples that we want to use and integrate into our robot code. Again, in just a minute, we'll look at LabVIEW, but what you'll do from that getting started window is you'll open the wizard to create a project. You'll pick a project that I have a circle around there. And then we're going to talk mostly about these pieces. So there's this README file. This has the information about the robot, so what's wired where. And then we have robot main, that's the main robot code. And then team code, which this contains things like begin and teleop, and we'll look at those pieces also. So for simulation, and we'll go in and run this, but we're going to run robot main. Notice down here we're going to run it on my computer. When you run that on my computer, this viewer opens up. And you'll see this is fairly small here. There's a robot on a field, and then you run the driver station. And then we'll look at one more slide here, and then we'll go into here. The other thing you can do is you can zoom in with this. You can zoom in, and this allows you to actually look at things moving, and you can check things like, are my wheels turning the direction I expect them to? Or is my gyro working the way I think it should be working? So let's take a look in LabVIEW. So here, I'm going to go to the getting started window just so you can see that. Here's my different tabs. So here's the tutorials. These are all built in that you can go through. Here's the support. Here's where you can find the example finder. And here's projects. Here's where you go and you can create a Robo-Rio project or a dashboard project. So I would click here, and I would just enter a name and my team number to create a project. I've already created one, so here's what the project we were looking at. Here's the robot main. Here's where the team code is located. Here's the robot simulation README file. We'll look at some slides with this for the input. But, if I open this, it's just an HTML file, and here's the list of what's on that robot. So you can't read it very easily. I have a better slide, but it tells me, how my left motor is connected, how my right motor is connected, things like that. So what I want to do is get all these pieces running, and it's a little bit tight on screen space here, but I think we can do it. So here's my driver station that you probably, if you run a robot, you're used to. Notice my joystick is connected. If I now run this, I'm set up on my computer. I can change that down in here. But I'm on my computer, so when I run it, the viewer opens up. And again, we're a little tight on space. But down here you can see that now it tells me I have a simulated robot, right? And so I can actually run this. I'm in teleop, and I can enable this robot, and then I can drive it in this simulator. And then I can zoom in and out here so I can see the whole field. I can zoom in, so I can really zoom, way in. And then if I'm turning the robot, I can see the wheels turn. So I can actually do some pretty good testing just to see if what I'm programming here works. And by default, the robot, the code to drive it already exists. But you can go in there and change things around. There's also, this isn't the only robot that you have available.